Okay, I want you to picture this. You're sitting on a small wooden boat. The air is heavy, tropical, and just perfectly still.
You're on the water.
You're on the water late at night, well past midnight, and you're just floating there on the dark surface of Lake Maracaibo in Venezuela.
And you look up at the sky.
Right, you look up, and you expect to see that typical, velvet blackness of a tropical night, but that is not what you see at all.
No. Instead, the sky, especially over the horizon where the river delta is, it isn't dark. It's pulsing.
Pulsing is the perfect word. It's this almost continuous flicker of light inside these enormous clouds.
Yeah, kind of silent electrical heartbeat.
It feels like being inside a colossal slow-motion strobe light. Every few seconds, the whole world, the water, the boat, the shore, it all flashes brilliant white.
And then it plunges right back into blackness.
And what really makes it so strange is the silence.
Exactly. You're seeing constant lightning, but you're not hearing that sharp, violent crack of thunder right above your head.
It's just nothing.
Or a low rumble. At most, a very distant low rumble. The light is so high up, the clouds can be 12, even 15 kilometers tall. So the light travels to you instantly.
But the sound doesn't?
The sound just can't keep up. It's too far away. So you're left with this eerie, silent light show.
And the key thing to get your head around is that this is not a passing storm. This can go on for 8, sometimes 10 hours a night.
And it happens maybe 150, 160 nights a year.
It completely challenges what we think weather should be.
This is Catatumbo lightning.
And today we're doing a deep dive into this so-called eternal lightning. We're going to look at the very specific mix of geography and wind that creates this perfect storm.
And we'll also explore how it became such a huge part of the local culture and what it meant when, in 2010, the lights suddenly went out.
It's a story about science, but it's also about a place and its identity.
Okay, so let's start with the basics. Let's just define the scale of this. Where are we exactly? And what are the numbers that make this place the lightning capital of the world? Right, so we are focused on the Lake Maracaibo Basin, which is in the northwestern corner of Venezuela.
A huge lake.
A massive body of water. And while the storms can be seen all over the area, the real hot spot, the most intense activity, is concentrated right where the Catatumbo River flows into the southern part of the lake.
And that's where the name comes from. It's named after the river.
It is. And if you go back to the language of the local Bariwi people who've lived there for centuries, the name Catatumbo translates to something incredibly poetic.
What's that?
The House of Thunder.
The House of Thunder. That says it all, really. It's not a place thunder visits, it's where it lives.
Exactly. And when you look at the raw data, you understand why. This isn't just frequent, it's a meteorological superlative.
So let's talk numbers. You said 140 to 160 nights a year.
That's right. And on those nights, the storms aren't just a brief flash, they are marathon events. They can rage for 8 to 10 hours straight.
So they start around sunset and just go all night.
Pretty much. And the intensity within those hours is, well, it's hard to comprehend. We're talking flash rates of anywhere from 16 up to 40 or 50 flashes per minute.
50 flashes a minute. That means the world is lighting up almost every single second.
That's what gives it that surreal, flickering, strobe-like quality. And the modern satellite data backs all this up.
What do the satellites tell us?
They've measured the density. And they found about 250 lightning events per square kilometer per year in that basin.
Wow.
Which is why it officially holds the Guinness World Record for the highest concentration of lightning on Earth.
So it's not just a title, it's a measured fact.
A measured fact. NASA looked at all the global data and officially named it the lightning capital of the world.
But long before NASA, people navigating the area had their own name for it, right?
They did. For centuries, sailors called it the Maracaibo Beacon.
A natural lighthouse.
A perfect natural lighthouse. The flashes are so bright and so high in the atmosphere, the glow could be seen from hundreds of kilometers away out at sea. It was a reliable landmark that guided ships to the coast.
It wasn't just a spectacle then, it was functional. It was infrastructure.
It was vital.
And this is where the story shifts from just measurements into the human connection. When something in nature is that constant, that powerful, it's never just weather, is it?
Never. It becomes part of the culture, a part of the mythology. It becomes a character in the region's story.
So let's go back to the indigenous peoples there. The Wayu, the Bari, they lived under the sky for thousands of years. How did they make sense of it?
Well, for them, it was all about power and respect. The lightning was seen as a manifestation of their gods, either their anger or just their immense power.
So a constant reminder every night.
A constant reminder to respect the forces of nature. I mean, if you live in the House of Thunder, you don't forget who's in charge.
And it was practical for them, too, just like for the sailors.
Absolutely. The sources are clear on this. It was a guiding light for hunters and fishers, helping them navigate home across the dark water after sunset.
And we see this thread continue, don't we? When the Spanish arrived in the 1500s and 1600s, they wrote about it immediately.
They did. They were stunned by it. These were men who had sailed all over the world, seen every kind of storm, and even they thought this was something special, something worth writing home about.
And then it gets woven into the national identity. I read about these legends from Venezuela's War of Independence.
Yes, the patriotic legends.
Oh.
The stories say that the constant glow from the storms was used by the independence fighters, the patriots, either as a literal navigation aid, lighting up their movements at night, or, maybe more symbolically, as a kind of beacon of resistance against the Spanish.
And it doesn't really matter if that's 100% historically accurate, does it? The fact that the story exists shows how deeply this thing is part of their psyche.
Precisely. The landscape itself was a patriot. And that brings us to maybe the most powerful symbol of its importance today.
The flag.
The flag. It's literally on the flag and the coat of arms for Zulia State, which is where the lake is.
That's incredible. A government has put a weather pattern on its official flag.
Think about what that means. For the people of Zulia, this isn't some tourist curiosity. It is a fundamental part of who they are. It's in their regional anthem. It says, "This is our place, the place where the sky never sleeps."
Okay, so that leads to the big question, the science detective story.
Yeah.
Why here? Why this one spot on Earth, and why does it happen almost every single night?
Right. For centuries, this was a mystery. But modern meteorology has basically cracked the code. And the answer is, it's a perfect dance of geography, moisture, and wind.
So let's break down the ingredients. What comes together to create this lightning factory?
There are 4 key ingredients, and they repeat almost daily. So ingredient 1 is the fuel, warm, moist air.
Okay.
Lake Maracaibo is a huge, warm, shallow, tropical lake, and it's surrounded by wetlands. So you have this constant, massive evaporation loading the air with water vapor. That's the fuel for the storm.
So you start with supersaturated air. What's next?
Ingredient 2, the topographic bowl. The lake sits in a basin, but it's enclosed on 3 sides by massive mountain ranges. The Andes, the Merida Range.
So they act like walls.
Exactly. They form a natural funnel, trapping all that moist air, with only one way out, north to the Caribbean Sea.
So the geography traps the fuel, but something needs to get it moving right. An engine.
That's ingredient 3, the Lake Maracaibo low-level jet. And this is maybe the most clever part of the system.
A low-level jet, so a specific wind pattern.
A very specific wind that kicks in at night. During the day, the sun heats everything up. But after sunset, the land on the mountains cools down way faster than the water in the lake.
And that temperature difference creates wind.
It creates a pressure difference that generates a strong, reliable wind. This jet funnels all that warm, moist air from the Caribbean across the lake and pushes it south, right towards the Catatumbo River Delta.
So the mountains cooling at night actively shoves all the fuel into one corner of the basin.
Precisely. It's a system that's perfectly designed to concentrate the maximum amount of energy in one spot. Which brings us to ingredient 4, the ignition.
What happens when all that moist air hits the mountains?
It has nowhere to go but up. It's forced violently upward.
Orographic lift?
That's the term, orographic lifting. And as that huge air mass rises, it cools rapidly, and all that water vapor condenses explosively.
Forming those massive thunderclouds.
Gigantic cumulonimbus clouds. They're packed with ice crystals and water droplets all rubbing against each other, generating the immense static charge you need for lightning on this scale.
So it's a perfect daily cycle. Daytime heats the fuel, nighttime wind pushes it into the mountains force it up, and you get a storm. Every night.
With astounding predictability. There's a climate study in 2016 that showed scientists can now predict the frequency of the lightning months in advance, just by looking at that low-level jet and larger climate systems.
What kind of larger systems are we talking about?
Primarily, Ian, the El Niño Southern Oscillation. It's that big fluctuation in temperature across the Pacific Ocean that basically dictates weather patterns everywhere.
Right, El Niño and La Niña. We'll definitely come back to that.
We will. It's critical to the story.
But before we had this elegant 4-ingredient explanation, people had some other ideas, didn't they? Some more exotic theories.
They did. For a long time, people were convinced there had to be something chemically unique in the air or the ground there.
The most famous one was the methane theory.
Right. The idea was, since the lake sits on top of huge oil and gas deposits and it's surrounded by swamps, maybe methane gas was seeping into the atmosphere.
And making the air more conductive.
Exactly, acting like an invisible wire that made it easier for lightning to form.
And there was another one too, right? Something about uranium.
The uranium theory. The hypothesis was that radioactive elements in the bedrock were emitting ionizing radiation, creating a charged path in the air that primed it for lightning strikes.
Both of those sound sort of plausible because they use features that are actually there, the oil, the geology. So why were they debunked?
The timing was all wrong. Later research showed that the lightning's frequency tracks the seasons of wind and moisture much, much more closely than it tracks methane levels.
What's the mismatch?
Well, the methane emissions from the swamps are actually at their highest during the dry season, but the lightning is at its most powerful during the wet season, when you have the most moisture and the strongest wind jet.
So the effect didn't line up with the proposed cause.
Not at all. The atmospheric engine, the wind and the water, is just so much more powerful. The methane and uranium are, at best, a tiny, tiny factor. The real magic is just simple physics: topography, moisture, and wind.
Let's shift now from the science of it to the reality of living under it. The communities there, places like Congo Mirador and Aloga. How do you live a normal life when the sky is a strobe light every night?
They have completely adapted. These are often fishing communities. People live in houses on stilts over the water, the palafitos. And for them, the lightning isn't a spectacle. It's just background noise.
It's the hum of the universe for them.
It really is. They are profoundly used to it. And the most telling anecdote about this comes from the kids doing their homework.
I read this. It's incredible.
Residents talk about how, during the frequent power cuts in the region, children would just use the lightning to see.
They would do their schoolwork by the light of the storm.
By the constant natural glow. Imagine trying to read while the room flashes from dark to bright every couple of seconds. It's a testament to their resilience, but also to the incredible consistency of the light itself.
The light is reliable enough to replace the power grid.
And for the fishers, it's still essential. It's their navigator, just as it was for their ancestors. It helps them see obstacles in the water. It's a fixed point on the horizon.
But for outsiders, for tourists, it's still this profound experience. How does that work?
When it's accessible, the tourism is all about that nighttime experience. Tour operators take people out in small boats deep into the marshes, and you just sit. You moor the boat, and you watch for hours in silence.
Just taking in the scale of it?
And that eerie quiet. But the sources are also clear that it's gotten much, much harder to get there.
Because of the situation in Venezuela.
Exactly. The country's economic and political crises have made travel and infrastructure a real challenge. And on top of that, the villages themselves, like Congo Mirador, are facing severe environmental problems.
What's happening there?
A lot of silting. Sediment is building up, turning open water into mud flats, which makes it hard to even get around by boat. That, combined with pollution, has caused a lot of people to leave.
So the very communities that are the gateways to this wonder are struggling.
It creates this painful paradox. You have this breathtaking, pristine spectacle in the sky happening above a human and ecological system that is under incredible stress. And that brings us to the environmental role of the lightning itself. It's not just putting on a light show, it's chemically changing the atmosphere on a huge scale.
Right, this is where it connects to the global environment. What is all that electrical energy actually doing to the air?
Okay, so globally, lightning is a huge natural source of something called nitrogen oxides, or NOx. The intense heat of a lightning bolt literally breaks nitrogen and oxygen molecules in the air apart, and they reform as NOx.
And what does NOx do in the atmosphere?
In the lower atmosphere, the troposphere, it's a key ingredient in the formation of ozone.
Okay.
And because Catatumbo is so intense, some scientists in Venezuela have argued that it's a major contributor to regional ozone levels. Some have even made the more ambitious claim that it could be helping to regenerate the global ozone layer.
That's a big claim. Is it widely accepted?
It's heavily debated. The general consensus among atmospheric scientists is probably not.
Why not?
It's about altitude. Most of the lightning at Catatumbo, while impressive, happens too low in the atmosphere to have a significant impact on that protective upper stratospheric ozone layer we worry about. Its main chemical impact is probably local.
So it's changing the environment right there, in the basin.
Exactly. That reactive nitrogen created by the lightning gets rained down into the soil in the lake. It acts as a massive natural fertilizer, which influences the fertility of the whole region's ecosystem.
So the lightning is a life giver. It brings the rain. It brings the fertilizer.
It does, but here's the profound paradox you mentioned earlier. This incredible, clean, natural spectacle is happening directly above one of the most polluted major lakes in South America.
This is the tragic part of the story.
It is. Lake Maracaibo is under extreme environmental stress. We're talking about chronic oil spills from aging pipelines, raw sewage from the cities around the shore, agricultural runoff full of pesticides.
And you can see it, right? It's not invisible pollution.
Oh, you can see it and smell it. It leads to these huge, thick algal blooms that cover the surface. There are oil slicks everywhere. The contrast is just stark. The brilliant, pure light of the heavens over these deeply troubled waters.
We've talked so much about how consistent and reliable it is, this eternal beacon, but nothing in nature is truly eternal.
And that brings us to the climax of this story, the moment the lights went out.
This was in 2010. What happened? What could possibly be powerful enough to shut down this engine?
It was that global climate pattern we mentioned earlier, ENSO. A very strong El Niño event kicked in.
And El Niño causes drought in that part of the world.
A severe regional drought. And that drought cut off the storm's fuel supply. The evaporation from the lake and wetlands plummeted, and the wind patterns that drive the jet were disrupted.
So the engine just seized up.
It seized up completely. For several weeks, some accounts say up to a couple of months, the sky over the Catatumbo Delta just went dark. It was the longest known interruption in over a century.
I can't imagine what that felt like for the local people. If your entire world, your entire culture is built around this nightly certainty, and one day it just vanishes.
It was terrifying. People genuinely feared it was gone for good. It shattered that whole idea of the lightning as this unbreakable, permanent force of nature.
But it did come back.
It did. Once the El Niño cycle ended and the rains returned, the system restarted. The moisture came back, the nighttime jet started blowing again, and the House of Thunder was back in business.
And that whole alarming episode gave scientists a crucial piece of information, didn't it?
A huge piece. It proved that the Catatumbo lightning is an incredibly sensitive natural indicator for these larger climate patterns.
It's like a canary in the coal mine for the regional climate.
Perfect analogy. Its intensity and its frequency track patterns like ENSO with incredible precision. Any change in the lightning's behavior tells us something is changing in the bigger system.
Which raises a pretty big question for the future. If a natural cycle like El Niño can shut it down, what happens with long-term climate change?
That is the long-term uncertainty. That delicate balance is fragile. Sustained changes in rainfall, rising lake temperatures, or large-scale deforestation on the mountains. Any of it could potentially disrupt the system.
Deforestation seems like it would be particularly bad. It would affect how the mountains cool at night.
It could weaken the whole engine. So while the lightning seems all-powerful, this eternal beacon is actually profoundly fragile. Its future is tied to the health of the climate, both locally and globally. So if we pull it all together, we've gone from this poetic indigenous idea, the House of Thunder, to the really elegant mechanics of atmospheric physics.
It's an amazing example of how nature can seem to glitch our sense of what's normal. Storms are supposed to pass. This one is a permanent feature, a machine.
And the incredible thing is it doesn't need some secret ingredient. No hidden methane, no uranium, just the perfect daily dance of mountains, warm water, and wind.
But it's also a story of duality, isn't it? It's proof of nature's power, but as that 2010 event showed us, it's also this incredibly fragile climate indicator.
Sensitive enough to track global systems, which proves that even things that seem permanent are connected to the health of the whole planet. And the lightning itself, by creating nitrogen, is essential to life in that region.
And that really brings us to the final thought for you to take away from this deep dive. While the sky above the Catatumbo is performing this dazzling, life-giving miracle every night, the real struggle for the future of that whole region is whether the troubled, polluted water beneath that legendary beacon can be saved.
That's it for this episode of Brain Binge. If you enjoyed getting your mind twisted tonight, do me a favor, comment, like, and subscribe so you don't miss the next deep dive. Got a weird fact, mystery, or place you want an episode about? Drop it in the comments. I read as many as I can, and I'm always hunting for new ideas. Thanks for listening, and thanks for letting your brain binge with me for a while. Stay well, stay curious, and I'll see you in the next one.